So this lesson is on more derivatives of trig functions, in particular using our various rules together with trig functions. So for example, if I want to know what is the derivative with respect to x of sine x plus cosine x, we recognize, of course, that the derivative of the sum is the sum of the derivatives. So that's the derivative of sine x plus the derivative of cosine x. The derivative of sine x is cosine x. The derivative of cosine x is minus sine x. So that our result would be cos x minus sine x. We, of course, could make a small adjustment to something like this and say the derivative with respect to x of 5 times sine x minus 9 times cos x. And same sort of thing, right? The derivative of the first minus the derivative of the second. So we would say the derivative of 5 times sine x minus the derivative of 9 times cos x. Then we can pull constants out in front, pull the 5 out in front. 5 times the derivative of sine x minus 9 times the derivative of cos x. The derivative of sine x is cos x, so that's 5 times cos x, minus 9 times the derivative of cos x. So we get 5 cos x minus negative plus 9 sine x. So again, the derivative of the sum is the sum of the derivatives. We can pull constants out using our basic rules of derivatives. Well, let's go with the more interesting rules of derivatives. How about the derivative with respect to x of x squared tangent x? This is going to require us to use the product rule. Let's remind ourselves of what that is. The derivative with respect to x of u times v is u prime v plus uv prime. So what's our u, what's our v here? U is x squared and v is tangent x. U prime is the derivative of x squared, which is 2x. V prime is the derivative of tangent, which is secant squared x. So that what we get is we get the derivative with respect to x of x squared tan x is u prime v, 2x times tangent x, plus uv prime plus x squared times secant squared x. Could work that way. We could also do one that would be a quotient, something like, what is the derivative with respect to x of secant x divided by the square root of x? If we're going to do this, we need to use the quotient rule, and let's remind ourselves of that. What is the derivative with respect to x of u over v? That, of course, is u prime v minus uv prime all over v squared. So our derivative here, our u, excuse me, is secant x. Our v is the square root of x, which is the same as x to the 1/2 power. U prime, the derivative of secant x, is sec x tangent x. V prime is 1/2 x to the negative 1/2. V prime is 1/2 times x to the 1/2 downstairs. So v prime is 1 over 2 root x. So we've got to put all this together in some kind of a meaningful way to be able to finish this derivative. So we can do that. And then simplifying it'll get a little tricky, but again, I think we can do it. So we're looking at the derivative of sec x over the square root of x. So u prime v sec x tan x times square root of x minus uv prime minus sec x times 1 over 2 root x all divided by v squared. All divided by v squared. What is v? V is the square root of x. All divided by v squared, all divided by square root of x squared. So, I mean, this is certainly not simplified, but I want to figure out some way to make that look a little bit cleaner. What I have upstairs and what I have downstairs. What I have upstairs is sec x tan x times the square root of x. Let's make sure we're clear on our notation here, right? Sec x tan x times the square root of x minus sec x times 1 over 2 root x divided by root x squared, which is just x. So I think I need to simplify my numerator. So how am I going to do that? Let's talk about the algebra here. So there's a couple strategies you could use. So the numerator, which I'll come down here and just show you. Numerator is sec x times tan x times square root of x minus sec x times 1 over 2 root x. I need to get a common denominator. The common denominator would be 2 root x. So multiply the bottom by 2 root x here. Multiply the top by 2 root x. And those would cancel out and leave me with what I had in the original thing, my original part of my numerator. So what does my numerator become? 2 root x is 2x, sec x tan x. All over 2 root x minus sec x over 2 root x. Which I can then write as a single fraction over 2 root x. So that my numerator becomes 2x sec x tan x minus sec x. That's the numerator. And what's the denominator? The denominator here is just what? The denominator here is just x. So I'm going to write my numerator down here. 2x sec x tan x minus sec x over 2 root x. That's my numerator divided by what's on the bottom. Root x squared is just x. So where does this go? Where does this go? Well, divided by x is, of course, the same as the sign times 1 over x. So this becomes equal to 2x sec x tan x minus sec x over 2 root x divided by x is the same as times 1 over x. And then we can finish this with 2x sec x tan x minus sec x over 2 root x times x, 2x root x. And we don't typically worry too much about rationalizing denominators in calculus. So I'm going to go ahead and leave that as the answer. But if you insisted, you could multiply the bottom by root x and the top by root x. But please do not cancel these x's. This is a binomial. You'd have to divide the x out of both pieces to be able to divide out the x in the entire fraction. So that is a problem with the quotient rule. And let's just do one more. How about one that combines a couple different things? What if I have the derivative with respect to x of x squared cos x over x plus 3. So there's a lot going on here that we need to keep in mind. We're going to start with the quotient rule. and then maybe do a product rule in the midst of the quotient rule. So let's remind ourselves of what that quotient rule is. The derivative with respect to x of u over v is u prime v minus uv prime over v squared. So what do we have? What's the top? What's the bottom? U is x squared cos x. V is x plus 3. Okay, how about v prime? V prime is the derivative with respect to x of x plus 3. The slope of x plus 3. V prime is just 1. But now what about u prime? U prime is going to take some work because I now have to do a product rule on top of that. Let's do a product rule within the quotient rule. And what will that give us? So this is where I use different letters or maybe capital letters to describe my differences. So here's my green information. Let me change colors, and let's say I want to do the derivative of x squared cos x. That's what I need. That's what my green u prime is going to be, right? This is going to equal green u prime. So orange u is going to be x squared. Orange v is going to be cos x. Orange u prime is 2x. Orange v prime is minus sine x. So what is u prime v plus uv prime? U prime v 2x cos x plus uv prime plus x squared times negative sine x. What do we get? 2x cos x minus x squared sine x. That's what our result is. That's what our green u prime is going to be. U prime v, 2x cos x, plus uv prime plus x squared times minus sine x. So we're going to go ahead and we're going to make that substitution up here. 2x cos x minus x squared sine x. Okay, now what? Now we've got to do some work and use our quotient rule. So away from the orange and back to the green. And what are we going to say here? Derivative with respect to x of x squared cos x over x plus 3. Again, is going to be u prime v minus uv prime over v squared in green. U prime v, okay. U prime v, 2x cos x minus x squared sine x. U prime v times x plus 3 minus uv prime u x squared cos x. V prime is just 1 all over v square all over x plus 3 squared. Well, that's a bit of a mess. Let's see, is there a way for us to simplify that? 2x cos x times x would be 2x squared cos x. 2x cos x times 3 would be 6x cos x. Negative x squared sine x times x is negative x cubed sine x. Negative x squared sine x times 3 would be negative 3x squared sine x. So that's just this binomial times that binomial, now minus x squared cos x. After all that, then what do we have left on the bottom? X plus 3 squared. You might want to multiply that out. I typically don't. I don't see much advantage to multiplying out the denominator. Now, is there a small chance something could factor here? Well, you could see we x squared, x, we can take an x out of all of these, but that's not going to make things a whole lot simpler. We're certainly not going to take an x plus 3 out of all of them. So I'm happy leaving that as my final answer.